Assalamualaikum. Good day, everyone. So today's lecture will be LU6, which is entitled Rapid Fermentation Process Development. And under this topic, we are going to look at a few subtopics, namely Miniscale and Microscale technologies in fermentation, and then disposable or single-use bioreactor technology, followed by application of high throughput technology in fermentation, and finally, process automation and analytical integration. Now, let's have a look at the first subtopic, which is Miniscale and Microscale technologies in fermentation. So, what is Miniscale and Microscale technologies in fermentation? But before that, this topic is basically concerned with the technologies that are used in fermentation. And these technologies differentiate modern fermentation from the old fermentation that has been practiced many, many years ago by our ancestors. So in this topic, we're going to see what are the development, what are the modern platforms that have been introduced by researchers, and also what are the concepts that being introduced as well, right, in order to improve the performance of fermentation in comparison to the old fermentation processes. Right, now let's have a look at the first concept, which is Miniscale and Microscale technologies. So what are these technologies all about? So before we relate it to fermentation, the technology per se, either Miniscale or Microscale, is a generic concept of technology based on processes and unit operations within mini-structured devices and microstructured devices, depending on the scale. If it is Miniscale, it's mini-structured. If it is Microscale, it is microstructured. Of a working volume between 1 and 10 milliliter for Miniscale and working volume of less than 1 milliliter for Microscale. So that is actually the definition of the technology. So as the name of the technology suggests, the process under this concept is to be carried out at a very small scale, which is up to 10 milliliter, the maximum. And it can be less than 1 milliliter. So if you imagine 10 milliliter it's not that really much. Actually, it's just like few drops. And even 1 milliliter is much lesser than that. 1 milliliter, if you think about the centrifuge tube, 1 milliliter is if you have 1 milliliter and less than that, it's just like a matter of few drops of liquid. So here we are talking about submerged fermentation, not solid state fermentation. Okay, right. So this technology, when it is applied to bioprocess or particularly fermentation, they are to be carried out. The technology is to be demonstrated or performed using certain platforms that are designed to cater the needs in small scales. So these platforms are known as mini bioreactors or microreactors, depending on the size. Or instead of the word reactors, they can also term as micro wells. Wells is just like a very small tube, cylinder tubes, or microfluidic formats. So microfluidic formats is much smaller than wells and reactors, where it is just like in terms of heat or flat surface, with very minimal amount of liquid to be applied. So there are various sizes, models, brands, and features of those reactors that are manufactured by different companies. So Miniscale and Microscale technologies, they are not new technologies. They have been around for at least like 2 decades. So 20 years ago that people introduced this kind of concept. And throughout that 20 years, there are many reactors, many brands, many models, many sizes, yeah, and also the reactors are designed to cater different needs or different applications. For example, for a microbial application, for animal or plant cell application. Okay, so in this topic, we are going to focus on the applications of Miniscale and Microscale technology for fermentations only. Having said that this technology is a generic concept of technology, it doesn't mean that it is only applicable to fermentation. Yeah, it's not only applicable for bioprocess, but it is actually applicable in a wide variety of fields. And even if you talk about bioprocess is a huge field. It's not just fermentation. Fermentation is only part of bioprocess, where fermentation is situated under upstream process. Under bioprocess, there is also another field called downstream processing, which concerns with the separation and purification of the product after the production through microbial or plant or animal fermentation. Okay, right. So when we relate miniscale and microscale technology with fermentation, so perhaps what comes to our mind is that the fermentation process are to be performed at miniscale or microscale. So you can just imagine that the working volume is really small, yeah, compared to the conventional scales like in normal shake flask or in normal bioreactor, right? So that is actually how the miniscale or microscale technology is integrated with fermentation. Right. When we talk about conventional platforms, before the technology of micro bioreactor or mini bioreactor comes into play, so people have opted the traditional platforms such as shake flask. Shake flask is the oldest technology, I can say, in bioprocess or in fermentation. Um, like more than 50 years ago, people have adopted for shake flask. So shake flask is basically is just like a flask, right? It's a glass flask where it is used to contain the culture, right? And the preparation of fermentation using shake flask is very simple. You just have to clean the shake flask and then fill in with the media that you prepare and then sterilize it. And once you sterilize it, you add the seed culture or inoculum, and then you put it on the shaker, incubator shaker, and you incubate it at certain temperature, then you can start the fermentation straight away. So it's very simple. But there are many drawbacks associated with shake flask. So you can see that it is not impossible to control the pH on shake flask, right? And also the dissolved oxygen, if let's say the culture is aerobic. So what is only possible to be controlled when we carry out the fermentation using shake flask is the shaking speed and also the ambient temperature. Yeah, so that's the only thing that perhaps you can control on a basic shake flask. So there are perhaps shake flasks that have been modified perhaps in order to include certain types of probes or sensors, but the basic shake flasks do not have any other control system. Yeah. So having said that, these limitations may affect the fermentation process because some fermentation processes or some microorganisms, they are very sensitive to pH change. So if they are to be incubated using shake flask, so there will be a problem. Perhaps the product of interest might not be produced at optimal level. Okay, so that is the drawbacks of shake flask. And another drawback of shake flask is the size. The size of shake flask is considered small. Yeah, of course you can increase the size of the shake flask, but what the problem that normally arise when the size is increasing in using shake flask is that the shaking or the mixing system will be affected. okay, because it's very challenging to mix big shake flasks and make sure that the mixing is perfect inside the culture. So those are the drawbacks of shake flasks. Even though it is considered as a very simple system, very cheap system, yeah, but the drawbacks associated with it, it has motivated the researchers to invent new platforms or to invent new concepts. So Miniscale and Microscale technology is one of them. Okay, one of the concepts being introduced in order to alleviate the drawbacks of shake flasks, right? So another conventional system, yeah, is the normal stirred tank bioreactor. So of course, the stirred tank bioreactor comes after the shake flask, but for example, like the single bioreactor, that is considered as a low throughput system. Although it has all the control system, the pH, the temperature, the dissolved oxygen, and the agitation system is much better than in shake flask, but the problem with the conventional bioreactor is the size. Is the size. So because normally people initially invented the bioreactor for larger production, right, compared to the shake flask, but they don't see the limitation associated with it, because if let's say you want to optimize, if you want to do like optimization studies, bioreactor might not be, the conventional bioreactor might not be suitable because of the large size, the large scale. So the conventional bioreactor, conventional low throughput bioreactor, normally designed in 1 liter, the scale, and that scale is considered actually quite big, yeah, quite quite big, quite large. Right, so that's one of the drawbacks of the conventional low throughput bioreactor. So the problem with that, if let's say we want to adopt the conventional bioreactor for optimization, is that we don't actually need to carry out fermentation at large scale. If let's say you want to still investigate the process. For example, if you want to optimize the culture parameters, because at the end you are not going to harvest the product yet. You just want to study and you want to improve it from time to time. So in that sense, conventional bioreactor might not be suitable. Okay, so that is actually the motivation why people have invented Miniscale and Microscale bioreactors, in order to facilitate the product development stage. Normally, the screening and optimization studies. Because when we want to screen, for example, screening of the microorganism, the best producer for certain products, okay? So we might not want to carry out large-scale fermentation yet. Yeah? And similar to the optimization studies, we just want to know what is the best temperature, what is the best pH, what is the best media. And after we get all the optimal parameters, and only then we translate it into large production. So that is actually the reason why people come with the Miniscale and Microscale technology, and they combine it with high throughput technology. So high throughput technology is another concept whereby the reactors are designed or built in large quantities, so that the fermentation process can be conducted simultaneously. For example, 6 reactors or 12 reactors or 24 or even 96. So it depends. The quantity can be either as low as 4 or can be as high as more than 100 reactors. So what is the benefits of having more reactors? Is because it can facilitate the optimization. You can carry out a lot of fermentation experiments at the same time. Okay, so that is another concept introduced, which is high throughput. I will talk about it later. So the Miniscale and Microscale, they have been proven, yeah, through the research, that the fermentation processes carried out at those scales are as efficient as those performed at the conventional large scale. So this has strengthened the point why miniscale and microscale technologies are relevant in bioprocess and especially in fermentation. So talking about the conventional platforms like the shake flask and the bioreactors, so I've mentioned about the limitation of shake flask and limitation of the bioreactor. So the microscale or microbioreactors, they actually sit in between the shake flask and conventional bioreactors, whereby they have small size, small scale, like the shake flask cultures, for example, but at the same time, the platform also offers control system, control environment. What I mean by control environment here is the pH, the dissolved oxygen, the temperature, and also the shaking or the mixing system. So it combines the benefits of both shake flask and conventional bioreactors. So that is actually the purpose of the microscale or mini-scale bioreactors. Okay, and not just that, mini or micro bioreactors, they are often automated. So what is meant by automated is that even though you have like high number of reactors or wells, but they are automated, they are standardized. So the process, the operation for all the reactors are standardized. So it can be just like you can just switch on the button for the shaking so that it will be all shaken. So you don't have to like operate each of the well separately. Okay, so that is the meaning of automation. For example, if let's say you have automation or automated process, something that is controlled by the machine, by the control system. Okay, so that helps the operation of high throughput microbioreactors. Right. So you can see the example of pictures over here, the bottommost here. This is an example of microbioreactor, high throughput microbioreactor. It's not just microbioreactor, but it's a high throughput microbioreactor, high throughput microbioreactor because they are altogether 24 wells, 24 reactors, microreactors that are operated together or simultaneously. And this is an example of automated microbioreactor, high throughput microbioreactor. So this is actually the Micro 24. Is a brand of microbioreactor produced by PAL. PAL is the name of the company. So you can see that this is the normal marker size. You can see actually it is how small the reactors, the microbioreactors are, right? And all of these actually consist of fermentation culture. So this is what I use for my PhD, and they are altogether 24 microreactors. So it means that I can run 24 fermentation or experiments at the same time. So that is the benefits of high throughput microbioreactor. And another point about micro or mini bioreactors is that you can see the small scale, the small volume of the culture. It does benefit the studies because it means that you can save the materials, the media that you are going to use for the optimization studies. And normally the media, they are not cheap. They are sometimes expensive. So if you use like instead of let's say 1 liter for conventional bioreactors, 1 liter, 1000 milliliter, you can just use 7 milliliter for one experiment or 5 milliliter, for example. If let's say you're using mini bioreactors, right? It's the range is between 1 and 10 milliliter. So 5 milliliter is way smaller than 1000 milliliter, and yet the performance is comparable. So why don't you opt for 5 milliliter? Because you can save a lot of media. So the media means money in the development of any product. So you can imagine like how much cost can be saved through the use of minimal amount of media introduced by the concept of Miniscale and Microscale technology. So that's one of the advantages of Miniscale and Microscale technology. All right, so what are the applications? So what are the purposes, the applications of Miniscale and Microscale technology? As I said just now, it can facilitate the optimization studies. So normally in optimization studies, we have many experiments to be conducted. So optimization studies refer to a study that aims to find the best parameters or the best condition for a process. For example, if you want to optimize temperature, you might want to know which temperature is the best for the fermentation. So you might want to test within certain range, let's say from 20 degrees to 40 degrees Celsius. Let's say you vary it by 2 degrees, 20, 22, 24, 25, or it can be 25 or 30 at 5 degrees interval. And you want to find at the end which temperature will give the best product titer, which temperature will give the best growth of the cells. So that is an example of an optimization study. And it can involve more than one parameter. Temperature is an example of a parameter. So it can be temperature, pH, shaking speed. It can also be the concentration of the media like glucose, the nitrogen source, and so on. There are so many. Yeah. So it means that the whole studies will involve many runs, many experiments, and these optimization studies can be facilitated by an approach or a software, by an approach called design of experiments, where the design of experiments, it will combine all the parameters to be studied, and it will give you a list of runs with different level of parameters to be tested. And that means that, the runs that you have to carry out in order to find at the end what's the best parameters for the process. Okay, so if let's say the number of experiments are like 48, 96, yeah, and it can be more than that. It depends on the number of parameters as well. So it means that you have to carry out lots of fermentation, quite a high number of fermentations, like 96 fermentation. That is not yet considering the replicates, not yet considering the errors. If let's say everything runs smoothly, which is not always the case, or not even the case at all, you might have to repeat. Yeah? For example, like 48 is just the number of ideal experiments to be carried out. Let's say you are talking about 3 parameters, but it doesn't mean that that is the only number of experiments that you will do. Let's say you have to repeat certain experiments because something's not going right during the work. So you have to increase the number. It could be not just 48, it could be like maybe 60 or 70. So you can see that the number of experiments under optimization studies is not little. It's not that it's not little. So it involves a large number of experiments. So that is when the miniscale or microscale technology, and if let's say it's integrated with the high throughput technology, will benefit the operators. Okay, so if let's say we want to carry out, let's say 96 fermentation, and with little volume, it's just like 5 milliliter for every fermentation, you can see how much media, how much money that you can save throughout the optimization studies. Okay, so the technology can facilitate the optimization studies in general, and then it can speed up the process development if let's say it is integrated with high throughput technology, which is always the case. Actually, the microbioreactor, it has normally, it's not just like one single well or microbioreactor. It is normally exists in high throughput platform or format. So if let's say you can run 24 fermentations at one time, And let's say you have 48 fermentations, let's say 48 fermentation, or maybe you have some more to be repeated. Let's say 72, considering all the errors and also the replications. So let's say 72. So it means that if, let's say, you have 24 fermentations at one time to be conducted, so if you need to run 72, means that you just run 3 times. 24 times 3, then you got 72, and all completed, right? Compared to if, let's say, you want to carry out fermentations using conventional bioreactor, like 1 liter. So you have to do like 72 times instead of just now 3 times, right? So that is the difference. And if, let's say, you want to carry out using shake flask, the problem with the shake flask is that it doesn't have the control system like the pH, the dissolved oxygen, and so on. So the results that you get, even though if you use shake flask, might not be as good as if you use microbioreactor. So that is when the microscale technology, when it is integrated with high throughput technology, it can benefit the process development because it can save the time. It can speed up the process. Yeah, right. And it can save the cost of the media because of the small volume. Yeah, and not just the media, the label, and also the energy. So when the size of the fermenter increases, actually, if, let's say, you are running, let's say, microbioreactors with 5 milliliter, but you have perhaps, of course, you have parallel microbioreactors, compared to if you have 5-liter reactor, 10-liter reactor, actually it is way more tiring to conduct 5-liter fermentation or 10-liter fermentation compared to if you run just like 5 milliliter fermentation. Okay, so that is meant by it can save labor and energy. And it's not just labor, it's energy as well, because the cost of the electricity, the cost of the water that you want to use in order to prepare, autoclave, and so on, it can be also reduced if you apply the microscale and the high throughput technology. Right. Miniscale and microscale technology is often automated and have online measurements of process parameters. So normally these microbioreactors, it doesn't only have the microscale kind of feature, but it has other things as well embedded together, like the high throughput concept, automation, and then when it is automation, it is connected to the computer. So you can actually observe or monitor the parameters online and even from your mobile. Yeah, I did that when I was doing my PhD. So having said that, it's very easy. You can actually see, or you can monitor your stuff, your experiments remotely, right? And that actually saves a lot of time as well, and it ease the operation. Yeah, ease the operation compared to if, let's say, you are dealing with a shake flask where it is not possible for you to automate the shake flask operation or to connect the shake flask system with the computer. There's no such way unless it's modified one, but you have to do everything manually using shake flask. So it would be laborious, it would be tiring, and perhaps if the number of the shake flasks that you are handling are large, you might need some people to help you, right? It can't be done by one person. So if, let's say, you are talking about at the industry, it means cost. Manpower is also one of the costs. So the miniscale and microscale technology has actually facilitated the process development in that sense. It saved the cost, it saved the manpower, it saved the time, and also it can speed up the process development.